Hello, good morning, class.
Hello. Yeah. Mercy, you can continue. Madam Mercy Mokere, you can continue. You are audible enough. Mercy, you can continue. You are audible enough. Unmute yourself and continue.
Good morning. You can hear me now.
Yes, Mercy, I can hear you. Can you continue? Mercy, I can hear you. You can continue. Madam Mokere, we can hear you. You can continue now.
Can you hear me now?
Yes, I can hear you. I can hear you. The students are also hearing you. Please continue. Hello. Good morning, everybody. There seems to be a network problem from where your teachers is located, but we are trying our best. Please hold on. Hold on as we try to come in. Just hold on. Thank you. Mercy, you're welcome.
Thank you. Good morning.
I hope you are now okay. Okay, continue.
Thank you. Now you can hear me now, eh?
Yes, I can hear.
Can you hear me?
Hear you.
Oh,
I can.
okay. Hello, you can hear me now, eh?
Yes, very clearly.
Okay. Good morning. And now we can move on. And at least we are lucky we are able to sort out that network problem. We were to look on the reversible reactions, looking on the previous lesson. Reversible reactions. Basically, we have got two types of reversible reactions. And starting with the definition of a reversible reaction, it is one that you can react substances to form products. And then when you have the products, you can still get the reactants. For example, when ice is heated, it melts to form liquid water. If that liquid water is freezed back, it is possible to get the solid. It is possible to get the solid ice. And so what is done on the solid ice? It is heated. Therefore, when substances are subjected to various conditions like heat, pressure, even cold, electric current, they can change their state, but no new substance is formed. No new substance is formed. Now, up to that point, are we together on a reversible reaction? Any questions so far? Okay. Types of reversible reactions. 1, temporary physical change. 2, temporary chemical change. So we can start looking on the characteristics of temporary physical change. 1, temporary physical change characteristics. The first characteristic is that no new substances formed. No new substances formed. That is the first characteristic of temporary physical change. The second characteristic is they are reversible. They are reversible. Temporary physical change are reversible. Temporary physical change are reversible. Number 3, for that reaction to take place, very little amount of heat is required. Just look at the amount of heat that is required to change ice to liquid water. Very little amount of heat is required. Number 4, on the characteristic of temporary physical change is that you can The amount of heat used is very retro, I said. The amount of heat used is very retro. Examples. I give the first example as melting of ice cold water. The other example, if you can take a substance like zinc oxide. What is zinc oxide? Zinc is a metal. And what about the zinc oxide? It is formed now when you take zinc, you heat it in water. So if you have that zinc oxide, when it is cold, it is white in color, but when you subject it to heat, the color will change from white to yellow. But it will still remain zinc oxide because there is no place. So still that one will be a temporary physical change because its chemical composition does not change. The chemical composition does not change. So now on that part of the temporary physical change, any question on that part before I move to the next, that is chemical change? Any question? Okay. Any question? Okay, no. So the next part is temporary chemical change. What is the difference between temporary physical change and temporary chemical change? Both of them are reversible. Both of them will require very little heat. Difference is that in the main difference between temporary physical change and temporary chemical change is that in the temporary chemical change, a new substance is formed. A new substance is formed. Example of a temporary chemical change. All of us knows about hydrated copper sulfate.
Excuse me, madam. Kelvin could be having some question. I'm seeing the hand is up.
Yeah.
Karaoke, what is your question? Karaoke, Kelvin has a question.
Okay, yes, go on.
Karaoke, what is your question?
I'm asking, these substances which are formed through temporary chemical change, do they go through a chemical process? Just like the others, temporary physical change go through a physical process.
It is temporary physical change. You can hear me?
Yes.
When it is a temporary physical change, it does undergo chemical. It does not undergo chemical change. You can hear me?
Yes, we can.
I am saying that they do not.
Yes.
Most of them do not. Hello.
when I was some more come and network is down. And I'll go after noon.
Are you okay, Kelvin?
Yes.
Can you hear me now?
Yes.
Can you hear me now?
Yes.
I am saying that when it is a physical change,
Yes.
the reaction
Yes.
does not undergo chemical change. That is, that reaction do not lead to a change in the chemical nature of that substance. We are together.
Yes.
The reaction, I have said that the change that is taking place when it is physical,
Yes.
it does not change the chemical nature of the substance undergoing the reaction. You get me?
Yes. What about temporary chemical change?
Yes. Now, when it is temporary means it is
Yes.
reversible.
Yes.
And when it is chemical change, it means
Yes.
the means that during the reaction,
Is a change? Yes.
a chemical composition of the substances that are undergoing the reaction.
It
Is
changes
it
the
clear?
chemical structure, chemical composition.
Yes. For example, when you have hydrated water,
Yes. Yes.
The
Yes.
chemical of that hydrated water is the salt plus. When you heat it, the water will evaporate. You can hear me? You can hear me? The water will evaporate. The water will evaporate.
Yes.
And so the composition of the compound now will be anhydrous copper. What is the that it was hydrated copper sulfate, and after being heated, it become anhydrous copper sulfate. So that is a chemical change, but the reaction is temporary. Because if you take the water that has been evaporated, you add it to the anhydrous copper sulfate, it will become hydrated again. That is what that makes it temporary reaction.
Yes, Dan Mwangi, you have a question?
Yes, Dan Mwangi. Dan Mwangi. Dan Mwangi, go on.
When you are talking about hydrated water,
yes.
What did you say about salt? Salt plus?
I said when a salt is hydrated,
yes,
it has got water that is chemically combined with that.
Madam Mukara, we can't hear you. We can't hear you.
Oh, you can't. Can you hear me now?
Yeah, though there's some breakups.
Can you hear me now? Hello, you can hear me now, eh?
Yes.
Yes.
Okay. I am saying that when it is a hydrated salt, it has the water of crystallization. And so when it is heated, when you subject heat, when you subject to that.
Not.
Yes, you can hear me.
No.
Oh, that's a problem. Can you hear me, Mr. Onyango?
Yes, but there are breakups. You're breaking, Yanni. You're breaking. You're talking as breaking.
Hydrated water, hydrated salt has got crystallization.
Hello, guys. How are you?
Fine.
Madam is having some network problem, so you just bear with her. In case there is anything you don't understand, just raise your hand. She'll come for your rescue. So done.
Yeah.
Bye.
Now we continue. We can continue with looking on the characteristics of the temporary chemical change. We look on the characteristics of temporary chemical change. Because it is temporary, then it is so that is characteristic. It is referred to. Number two. Number two. Number two is that heat change is involved. Why is heat change involved? It is because the starting temperature of the reaction is raised. When you are heating, you are raising or you are changing the temperature. So there is reaction. Yes, Jude. Yes, Jude Mutai. Jude Mutai, can you hear me? Yes, go on.
Teacher, please can you repeat the characteristics? I've not had the first one.
The first one, temporary chemical change. The first one I have said it is reversible. That is why we are calling it temporary. So it is, the first one is reversible. Clear? Then number two, I said heat changes involved in the reaction.
Thanks.
How is heat? Yes? Okay, you're welcome. We can continue. Characteristic number two, heat change is involved in the reaction. Heat change is involved in the reaction. How? Because when the substance is being subjected to heat, the temperature is increasing. Then number three, there is change in mass. There is change in mass. What does that mean? At the end of the reaction, the mass of the substances will have changed. Let's take the example of the hydrated copper sulfate. When it is heated, the water of crystallization evaporates. Meaning that when you weigh the anhydrous copper sulfate, it will be having less mass than the original one. Why? Because some mass that had been weighed has already evaporated. That is, the water has evaporated. So That is what that you need to change in the mass. Then the last one, a new substance is formed. A new substance is formed. The starting substance was what? Hydrated copper sulfate. What color is hydrated copper sulfate? Blue. Then when you subject it to heat, it loses the water of crystallization. It changes to anhydrous copper sulfate. And then the color will turn to white. Why is that reaction reversible? If you now take the water that has come out from the salt and you pour it on the anhydrous copper sulfate, which is white, the color will turn again to blue. The original color will be attained, to mean that you have reversed the reaction. You have reversed the reaction. Up to that point, any question? Any question on temporary chemical change? I have given one example of heating hydrated copper sulfate. Let's give another example. Let's think of another example of temporary chemical change. Anyone with an example of temporary chemical change? Stephen Moreithi? Stephen Moreithi? Yes, Kevin Mwangi.
Okay, another example of temporary chemical change is heating hydrated cobalt-2 chloride.
Yeah, very good, very good. That is hydrated copper-2 chloride. What color is hydrated copper-2 chloride? Before you heat it, what is the color?
Before you heat it, it's pink. When you heat it, it turns to blue.
Yeah, so that is a very good example, a very good example. Yeah, when you heat it, it will lose the water of crystallization and the color will turn from pink to blue. A very good example. Yes, Stephen Mureithi.
Yeah, one who has answered that one.
Okay, yeah, that is very good. We can continue on. Any other person with a question? So up to that point, then we can be able to give the differences between temporary physical changes and temporary chemical change, the differences. I am now posing the question to anyone who is able to give us a difference between temporary physical change and temporary chemical change. Anyone who is able to, yes, Alex Boy. Yes, Alex Boy.
In temporary chemical change, there are new substances formed. A new substance is formed, but in a temporary physical change, no new substance is formed.
Yes, a very good one. Correct. Justin. Any other person with a question? Yes. I can't hear you. Can you hear me? Okay, good morning.
In temporary chemical change, there's a change in mass, while in temporary physical change, the mass of the substance does not change.
Yes, correct. Very good. The next is Manuel.
Excuse me, teacher.
Yes.
I had a question on the examples of temporary chemical changes.
Go on.
Shall we say that ice can be one of the substances that can go to temporary changes?
Yes.
What about if we say even fresh water can go the same as ice, the same changes as ice, because fresh water can be cooled down to form ice and then heated to go back to its original state.
Yes, that one now is a very good example of a temporary physical change. We agreed
So
on
we,
that because
uh, excuse me, so it means we can say both the examples are both ice and also fresh water.
that example of the ice cold water turning to
Yes.
liquid water, that one is a temporary physical change because there is nothing new that is being formed. It's only that it is changing the state from solid state to liquid state. Yeah, so
State.
that one is basically a temporary physical change.
Okay.
Yes.
What about water, fresh water?
What do you mean? Fresh water changing to what? The state, changing its state.
Yes, changing its physical state to ice and then changing to its original form of the fresh water when you heat it. When you heat the ice.
Yeah. We are. I think we are. You are getting what I'm saying. When a substance When a substance does not its chemical nature,
Yes.
the reaction is poor. When a substance does not change its chemical nature, it is only changing from one state to another, then we
Yes.
say that reaction is physical. Why is it physical? Because its chemical
Because it is
composition,
changing from. Yes.
yes, because it is the state, when it changes the state, nothing is changing. It is only the particles in solid are closely packed, and now in the
Yes.
liquid, they are not as closely packed as in the solid. But there is nothing that has changed. It's only
Okay.
the
They when in solid they are closely packed.
yes.
Okay, I've understood now. Thank you.
Okay. Let's
Credo.
okay. Please just mute your microphones. We can have we can have silence. Yes, Eugene, Eugene, go on. Yes. Any question? Any
Yes.
question?
The question
Yes,
is,
yes.
there was a point we said that heat, when we are talking about temporary chemical change, there's a point we
Mhm.
say the heat is evolved or absorbed. What do we mean by that?
I pardon your question. I said heat is given out or heat is absorbed.
Yes. So,
You can
yes.
hear me. When
Yes.
I said that heat change is involved, that is when there is some substantial heat change that you can note. That is, if you are to measure the temperature using a thermometer when that reaction is taking place, it is possible for you to note the thermometer reading from one reading to another. That is, you are able to tell that there is a change, there is heat change that is taking place, so that the reaction can take place.
Okay. Okay, thank you.
Yeah, you are welcome. I think now we can, is it possible, if you have a question, you can just send it through the chat. Any other question that you have? As we move on thinking of the similarity between physical change and chemical change. The similarities of the physical change, temporary physical change, and temporary chemical change. The similarities between physical change and chemical change.
In the physical, the similarity between physical and chemical change is that they are both reversible because they're temporary. If they are temporary only.
Yes. If they are temporary physical change and temporary chemical change, the similarity is that both of them are reversible. Very good.
In both, for the reaction to take place, the heat change must be involved.
Yes, there must be some change. There must be some change in heat. Yes.
Excuse me, Jeff.
Yes.
In the book, it says that temporary physical changes are not accompanied by heat change.
You said?
In the book, they say that temporary physical changes are not accompanied by heat change.
I have said that the temporary chemical change, you can hear me?
Yes.
It is accompanied by heat change, or a lot of heat change is involved. But for the temporary physical change, the amount of heat that is involved.
Yes.
It is not heat that is when we talk of the net heat change.
Yes.
It is not heat that can be measured. It is not a lot of heat, I mean. The heat is not a lot, but remember, why we are saying there is heat change. You can hear me?
Yes,
is because can ice melt just at a normal, can ice just melt when there is no change of
no.
Why in physical change, they are not accompanied by net heat change, but in both of them there must be change in temperature.
Yes.
You get? Yes, because ice cannot just melt, just like that. So there must be some change in the
Okay, thank you.
It clear now? Okay.
Yes.
Any other? Yes, move on. Okay, is it?
Yes.
Okay, this is.
Excuse me, Chuck, can you talk of in both temporary physical and
temporary chemical change, there is always a change in color.
No, 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 no. That one cannot apply. The reason is because in the temporary chemical, that is where you are able to see the color change very well. You can be able to see the color change. And then in the temporary physical change, the color change may or may not. So it may be seen or it may not be seen. So that is why we cannot generalize and give that one as a similarity. Though in some cases, there is such change. For example, the example of the zinc oxide, it is physical and the color changes from
White
to yellow.
White. So that one is one example.
Okay. Thank you.
Let us now just continue looking on the assignment that I want to give to you. So the assignment yes, Stephen. Stephen.
Yes.
What do you mean by net heat change?
That question was asked earlier on. I was saying that when a reaction is taking place, I can just move back a bit. When a reaction is taking place, there must be some conditions that are causing that change. And one of those conditions is the temperature. For the ice cold water to turn to liquid water, there will be some slight temperature change. Minimal, the amount of it will be minimal. But now when it comes to hydrated copper 2 sulfate, the amount of heat is it's a lot of it. So that is why then we go ahead and say for the temporary chemical change, the heat change is mutable. The heat change is mutable. For the temporary physical change, the heat change is not mutable, or it is not of heat. Can you hear me?
Yes.
Yes. Now, are you able now to see the difference between the change in the physical, temporal physical, and temporal chemical?
Yes.
Yes, but in the physical one, the heat is just slight. You only need very little heat to make the ice melt. But for you to remove the water of crystallization from hydrated copper sulfate, the amount of heat is notable. It is a lot of heat. That is why we are saying you can see or you are able to measure that heat change. So for the temporary chemical change, the heat change is involved or it is, that is, it is either absorbed or it is given out.
Yes.
I think up to that. Yes.
Yeah, I've understood.
We can. Yes, we can then. We can then move on. We can move on. Before we start with the permanent change, I wanted to give you some questions on the same, whereby I expect you to use the KLB book. I believe you have the KLB book. That those questions that are on heating of hydrated copper sulfate.
Iko sawa sawa. Yuko anataka kushare screen, anataka kutuuliza maswali.
Now that is, I was saying, yeah, we have, we can have these, you are able.
Excuse me, teacher. Excuse me, teacher.
Yes, yes.
What was the second point on the similarities?
Are you able to see the photo?
Excuse me.
Yes, you can hear me.
Yes.
Excuse me, teacher.
Yes. Now looking at, yes, I can, yes, karaoke.
Excuse me.
Yes.
There was a point which you said heat is involved in the reaction when you are talking about the similarities between the two.
Yes.
Can we say
Yes.
these are external conditions instead of it, because
Yes.
Because there is also pressure when you expose a liquid, let's say, yeah, a liquid to a lot of pressure or a gas. It changes state to a liquid, and there was no involvement of heat, but there was only pressure. And we talk of
that one you are very right.
In general, yes.
Yes. Yes. You are very right that for any change to take place,
yes,
pressure can be involved,
yes,
or cold or electrical current.
That is why I was saying we talk in general. Instead of it, we talk of external conditions are involved so that they can be a change in the reaction.
That is exactly what I said at the beginning. At the beginning, I said that for any reaction to take place, what is bringing change can either be
heat
or cold, or electric current, pressure. Yeah, those conditions, pressure, heat, cold, or electric current. But for the examples that we are looking on today, they are involving raising temperature, raising of pressure. That is why I'm talking of heat. That is why I'm talking, because we are using examples that are talking of raising of temperature from a lower one to a higher one.
A higher one.
Yes, that is melting of ice, heating of copper hydrated sulfate.
Yes.
The examples that I am using are specific, they are a bit specific on the raising of temperature.
Thank you.
Okay. Are we looking on the questions that I have put on? The screen shared photo is the one that I wanted us to look on. We are looking on the first one. What is observed when two sulfate crystals are heated? As you can see on the diagram, temperature is being raised, and so raising of temperature will cause a change on raising of temperature will cause a change. And so what will happen to copper 2 sulfate crystals? They will change the color from white. What else will be observed when the heating is taking place? Remember, water is being evaporated. So you'll be able to see colorless fumes will be seen emanating or originating from the boiling tube, because on the diagram, the boiling tube is one that is being used. And so that water that is coming out was chemically combined. It was chemically combined. Now it is coming out through the delivery tube. Then in the process, it is getting condensed. And then when it condenses, by the help of the ice cold water, then it will become a colorless liquid. So what is the colorless liquid? It is water that has formed as a result of, condensation of the water vapor. Now, what if instead of copper 2 sulfate, cobalt chloride is used? As somebody gave us that example. Cobalt chloride, when it is hydrated, it is pink. Then pink. When you heat it, it will blue.
It will turn to blue.
See? We're together on that. Then question number 2, so that we can complete quickly. When a few drops of tap water are added to the product, what is the product of 1A? Anhydrous copper sulfate, which is white. So when you add water, what will happen? It will turn blue.
Again.
That is reversible. The reaction.
It will turn back in cobalt 2.
What will happen if you had used cobalt 2 chloride, which was pink before it was heated, and then it became blue when it was heated? Turn the cold water and add on the blue cobalt chloride. The blue cobalt chloride will turn to
pink.
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 Then question number B. Yes, question number B. The liquid corrected in A and B is added to the residue in each case. That one we have already answered. Identify the liquid corrected. The liquid, of course, is water. Classify the changes. The change is
temporary chemical change.
Temporary chemical.
Change.
It is reversible. There is change. Then there is change in mass because one of the reactant has been removed. Then a new substance.
A new substance is formed. Excuse me, Chair.
Yes, if you have got a question, you can just send it through the chat. Yes, go on. Go on.
In the temporary physical changes, are there any forms of chemical reactions?
I think that's a very good question. Good question. To answer that question, it is important to note that when a temporary reaction is taking place, some of those temporary reactions, they do not adapt or they do not change their chemical nature. They are the ones that now we call physical change. But if a temporary or if a temporary change is undergoing chemical change, is the one we call temporary chemical. Is it clear?
Changes. Yes.
Yes. Yes.
Yes. Yes.
Yes.
Yeah, it is clear.
Temporary do not look at chemical change.
Yes.
Any other? Any other? Why don't you just start the question through the chat? I want us to add the lesson. And if you have got any question, I thought that it is better you said it through the chat. Let's add the lesson, and because there are no other questions, we can just add the lesson and have a good day. Continue looking on the permanent